So I'm going to talk about functions here, and the whole idea is that you're going to understand basic information and definitions involving functions. So there's a lot of fancy definitions out there, but what I want you to understand is that a function is just an input and an output table. And you actually were probably introduced to input and output tables back in 5th grade or so. But the first time you really got used to one was when you were asked to graph a line. The first time you probably graphed a line, they told you to set up an XY chart, and you would have picked 3 different numbers most likely, or at least 2. One of them being 0, maybe it was -1, 0, and positive 1. You took those x values, you plugged them into your function, or your y equals mx plus b, and simplified it down to find the corresponding y value. So that's exactly how the function works. You pick an input, you plug it in, and let the function or the rule of that input decide what the output or the y value is. So one of the other things that I want you to understand is that you are in control of the input, and the function is in control of the output. Okay, there's some kind of like definitions we need to all understand. Usually you see this as your function name, and it's pronounced f of x. As far as I can understand, the only reason that it's f is because function begins with an f. Any of these are acceptable, and any letter out in front of your x is fine. This would be g of x and h of x. What I would suggest is if you are using more than one function at a time, then you should give them different names. Otherwise, I'll probably always refer to them as f of x. Okay, another thing you have to be able to keep straight is that f of x is exactly the same as y. They are interchangeable. You know, this is what you would call y equals mx plus b form. But f of x equaling the same rule is giving you the exact same information. But I guess I would argue that this is actually going to give you more information because you can actually see what the input is at the time. Keep in mind that x is just a placeholder. Okay, it's just wanting you to evaluate whatever's inside these parentheses. In this case, it's just x right now. And so anything inside the parentheses you're going to plug in and simplify to get its output. This example I have is not related to the rule above. So what this statement is saying is that, well, it's read f of 3 equals -7. And all it means is that the input was 3 and the output was -7. Your x is 3, your output is -7, your y is -7. Okay? You could write that as a coordinate if you would like, because they do come together. So make sure you understand that functions don't keep the inputs and the outputs separate. They come together as a pair. You have an input, and then you have an output that goes with that input. Now, the inputs and the outputs can go by different names. You know, you can call them x's. The fancy name to say inputs is domain. Outputs can be called either your y's or your range. So all 3 of these terms in each of these lines can be interchanged as you wish. I said this a second ago, but this is very true. The input is controlled by you, or maybe more specifically, the situation. You know, you use inputs to find out the output during that time. So, you know, what is happening at, for instance, this time? You know, a lot of times you'll see graphs where the x values are time, and that would be what your input would be. Excuse me. The output is out of your control. The rule of the function is what controls what the output is. Again, inputs are very boring. You're just going down the x-axis and plugging in different x values. The outputs are what makes a function interesting. And that last statement is what gets a lot of people confused about inputs. What's going on? There we go. Or I'm sorry, that's what gets people confused about functions. So a question that you would have to think about is where a function is positive. So in the previous page, I was talking about a function, which is f of x, is the same as a y value. So if you're asked to think about a function, what you're really being asked about is their y values. Okay? So these are the important parts of a function. You know, what's going on with the y value. The where in this case refers to the x values. And that's what makes it a little confusing. You got to switch back and forth between x's and y's as you go. But if you're talking about a function, you want to think of your y values. So in this question, you know, there's two parts. Where is the function positive and where is the function negative? If we're talking about functions and we're talking about our y values, where it's positive is up here in quadrant 1 and in quadrant 2. Where it's negative is down in quadrant 3 and quadrant 4. So this part is where the function is negative because it's below the x-axis. This function is also negative down in this area. Where is it positive? Well, up above the x-axis, we're getting positive y values. Our function is positive there. So in both of these locations, we have positive values. Now there's different ways to write this. I just want you to use basic inequalities. So to answer the question fully, where is a function positive? Well, when in this case, when x is less than negative 4, so all of these, right, this means it's never coming back. All of these, all the way down into infinity, always produce a positive y value. And then in between negative 1 and positive 4, right, that's what this says, in between negative 1 and positive 4, you're also getting positive y values. Your function is positive right there. Flip it around. Where is it negative? Down here below the x-axis. So from negative 4 to negative 1, right, from when x is between negative 4 and negative 1, then you have a negative part of your function. And then also from 4 to infinity, right, it's never going to come back, go on and on forever. That's also, as x increases, right, as x keeps getting bigger, all of those values are going to produce negative y values. So you got to get used to going back and forth between these two. And once you really get that idea of how the inputs are kind of boring and just stay the same, right? Your inputs are always just on this axis. Boring, negative 4, negative 3, negative 2. They're never changing. But depending on what the function is doing, you get all kinds of interesting effects for those same inputs.